Multiplying fractions. Always remembering that a fraction is just a division problem. 3 divided by 4, that's 3/4 right there. When we are taking a fraction, like 3/4, and multiplying something by that, we're saying we're cutting it 4 times and then taking 3 of those pieces, right? The denominator is telling us how many pieces, how many times we're cutting it to make our smaller pieces. And then the numerator, 3, is telling us how many we're taking. Always remember that if you're multiplying by a fraction that's smaller than 1, so a proper fraction, your answer is always going to be smaller than what you started with because you're saying, oh, let's only take 3/4 of that. It's going to be smaller than the whole. If you're multiplying by an improper fraction, like 7/4, you might have a bigger answer than you will have a bigger answer than what you started with. But a proper fraction is always making it smaller when you multiply. So you probably learned the trick for multiplying. And for the trick, you just multiply straight across. You say 3 times 2 is 6, 4 times 5 is 20. And like this is correct right now. We have the correct answer. It's not simplified, so we're going to simplify it also. I'm going to divide by 2 on the top and bottom and get this down to 3/10. That's simplified now. But both of those answers were correct. 6/20 and 3/10 are equivalent. Okay, so that's the trick, right across. Multiply the numerators, multiply the denominators. So why does this work? When we take 3/4 and multiply it by 2, 2, remember, is the same as 2 over 1. So when we multiply, we are only changing the numerator, only changing how many pieces we're choosing, right? And when we multiply that by that 1/5, which, reminder, is the same as dividing by 5, that's only changing my denominator. It's only changing how big these pieces are. So together, multiplying by 2 is only changing how many pieces. It's only changing the denominator, the numerator. And multiplying by 1/5 is only changing how big the pieces are, the denominator. So that means, we can do those 2 steps in one where we only have to multiply the top with the top, how many pieces, and the bottom with the bottom, how big are the pieces. So if you're happy with the trick, you can always do the trick, but I am going to show you a visual representation of what this really means. So our problem, remember, was 3/4 divided by 2/5. And the way that we represent this is I'm going to start by drawing 3/4. So I'm going to color these in, pretend these are nicely colored. And now to divide it, oh my gosh, I'm so sorry. We're multiplying by 2/5. Let's fix that. We're multiplying by 2/5. So the first thing we're doing is splitting those fourths 5 times, right? To make them into those smaller denominators with that divided by 5 on the bottom of my fraction, that 2/5. So I'm going to cut it 1, 2, 3, 4, and 5 pieces. And now I'm taking 2 of those. So I'm going to grab a different color. I'm taking this and this. So when I'm trying to figure out what my actual answer is here, you're like, great, you drew a rectangle. What does it mean? We have 20 pieces. So my problem is in 20ths. And then the pieces that I want are where the 3/4 and the 2/5 overlapped. So where we colored in with both colors. So it is these 6 pieces right here. 1, 2, 3, 4, 5, 6. 6/20ths. So if your brain likes pictures better, you can always draw out multiplying by fractions. And sometimes it'll help you see those pieces. Remember, we cut into 5 pieces, and then we shaded in 2 of those sections. And then the double shaded was our answer. Quick examples. You can absolutely draw these out, but if you'd like to just do the fast way, we're going to multiply the numerators. 2 times 3 is 6. 7 times 4 is 28. We're going to stop and see if we should be simplifying this fraction, and I think we can. Let's divide it by 2. Now we have 3/14. That's not going to get any simpler. Here we've got 4, 1 times 4, and 5 times 9 is 45. That cannot get any simpler, so that one is done right now. That's multiplying straight across, easy peasy. Dividing. So before we actually get into doing dividing fractions, you probably remember the trick, but before we get into that, just think for a minute with me about what dividing even means, okay? The problem 12 divided by 4, what does that mean? You probably know the answer is 3. Why? So there's two ways to look at division. One way is we're splitting 12 into 4 equal groups. Each group has 3 pieces in it. The other way is we're saying we have 12 pieces and we're saying how many groups of 4 are there in that group of 12? And there are 3 groups. Each group has 4 in them. These are just two different ways of thinking about what division means. We're going to apply them to fractions now. So when we have the problem 12 divided by 1/2, there's the two ways of looking at division, right? The first one is harder though with fractions. Dividing 12 into 1/2 equal groups. What is a 1/2 group, right? Before we were splitting into 4 groups. I know what that means. What does splitting it into 1/2 groups mean? It's a little bit harder. When we think about the second version, divide 12 into groups of 1/2. That's saying how many 1/2s are there in 12? So bear with me while I draw 12. 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, we'll put it over here. 12. How many halves are there? Well, this one has 1, 2, and then 3, 4. And as we count along, there are going to be 24 halves in 12 because each whole has 2 halves in it. Okay? So, knowing this information, do this division problem in your head. 2 divided by 1/2. That's saying how many 1/2s are there in 2? Think about it. When you're ready, I'll tell you, or just keep watching, that we have 2 wholes, we cut them in half, and there are 4 halves in that. Now that you know 2 divided by 1/2 is 4, can you do 6 divided by 1/2 in your head? Picture those 6 wholes. Each one of those whole units, when we cut it into halves, we have 2 pieces. So 2 for every 6, we should have 12. All right, 4/5 divided by 1/5. Remember that the denominator is just like a unit. This is the same as saying 4 centimeters divided by 1 centimeter, or 4 oranges divided by 1 orange. How many groups of 1 are there in 4 of them? And there's 4. Okay, a little bit harder. Can you do this one? Picture your 4/5. We're dividing by 2/5 this time. So that's saying how many 2/5 are there in 4/5? And because we have the same units, we can really just ignore these. We're saying take those 4 pieces I have, divide them into 2 groups of 2, or how many 2s are there? There's 2. So just like we had visuals for multiplying, we also have visuals for dividing. Imagine I have my 5/7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. When I'm saying 5/7 divided by 1/7, I'm really just saying how many 1/7 are there in these 5/7. And you can see them. 1, 2, 3, 4, 5 of them. Let's do a little bit of a harder one. If we start with my 5/7, and now we see how many groups of 2 are there. Here's a group of 2. Here's a group of 2. Ooh. And here's one is shaded, but the other is not. So I have 1 whole group and 2 whole groups. I have at least 2 2/7 in 5/7. And then my leftover one is only half full, so it's half of a 2/7. So there are 2.5 2/7 in 5/7. This drawing picture gets a little more complicated when you have different denominators, but you can still use it. I'll show you how. So your options when you have a problem, like 3/4 divided by 1/5, and we're going to do all these options today. You can convert it to decimals. You can draw yourself a picture. You can change it into a different equation, like 3/4 is just 3 divided by 4, right? You can use the inverse, and there's also a trick. Of course, there's a trick. You maybe remember the trick right now, and you can always use the trick, but why does the trick work? The most important thing I want you to think about, though, when you're doing these questions is like, what does this even mean, right? It means how many 1/5 are there in 3/4, and you do probably have a sense of that. If you picture a picture of 1/5 and a picture of 3/4, could you fit a 1/5 into a 3/4? If you can, then your answer is going to be bigger than 1 because you can fit at least 1 in there. If a 1/5 was bigger than a 3/4, we wouldn't be able to fit a whole 1 in, so our answer would be less than 1. So 3/4 divided by 1/5, because I know 1/5 is smaller than 3/4, I know I'm going to be able to fit at least 1 in there, so my answer is going to be bigger than 1. Let's try it. So one way to divide is to just turn them into decimals. You, of course, can do this. You're going to turn each number into a decimal by using that bar to mean divide. If you do 3 divided by 4 in your calculator, it'll get you to 0.75. And now you can just divide with decimals. Listen, you can do it with long division, you can do it by clearing the decimals, you can do it in your calculator. The only trouble with changing to decimals is you'll get a decimal answer at the end. And if you need to change it back to a fraction, because the question asks for a fraction answer, it's a little bit of a hassle. A picture. When we are taking 3/4 and turning it into 1/5. Here's my 3/4. I'm sorry, we're not turning it into 1/5. We're dividing by 1/5. We're trying to see how many 1/5 we have in it. We are going to start by doing this cut. So we're going to cut everything 5 times, well, not 5 times, but into 5 pieces from what we had. And now we're looking for groups of 1/5. The trouble is, what does a 1/5 look like in this big rectangle I drew? It has 20 squares in it, so 1/5 of this rectangle is 1, 2, 3, 4 pieces. So we're looking for 4 pieces. So we're going to go through and circle all of the 4 groups we can. Here's a group of 4, and here's a group of 4. Here's a group of 4, and then, oof, I only have 3 left. So this right here is a 3/4 full group. So I had 1, 2, 3 full groups, and then 3/4 of a group. That means 3/4 divided by 1/5 is probably, I hope, 3 3/4. So changing the equation, this really turns into decimals, but just remember, you don't have to have any fractions in this problem. You can take all the fractions out and put division symbols in, all the fraction bars, because the division symbol and the fraction bar are equivalent to each other, right? This is usually going to become decimals for most people, but you can, if fractions give you major anxiety, you can always do this and turn it in to a different equation, right? I mean, it's the same equation, but it looks different. The other thing you can do is, because dividing is the inverse of multiplication, it undoes multiplication, you can always take this and change it to the inverse operation times and the inverse number. So 1/5, the multiplicative inverse of that is 5/1. And the reason for that is 1/5 times 5/1 cancels to 5/5, which is just 1, right? So multiplicative inverses always multiply to 1, because remember, 1 is the nothing of multiplying. So 3/4 divided by 1/5 just turns into 3/4 times 5/1. And now we can use our multiplying rules that we already know. 3 times 5, 15. 4 times 1, 4. We could even turn this into a mixed number if we wanted. It's 3 3/4. How lucky. So remember, dividing is the inverse of multiplying, just like subtracting is the inverse of addition. And of course, there's the trick. You probably learned the trick in school. Keep change, flip. You can always use the trick. I just want you to know why it works, okay? We keep 3/4 the same because this problem is starting with 3/4 and then doing something with it, right? Dividing by 1/5, trying to find how many 1/5 are in it. Change, we're going to change dividing into multiplying because this is really just multiplying by the inverse. And then we're going to flip 1/5 to 5/1, right? So this is just multiplying by the inverse, but it's like a shorter, sweeter way to remember it. Keep, change, flip. 3/4 stays the same, and then we do our inverse operation with the opposite number, okay? And then, again, we just multiply right across. 3 times 5, 4 times 1. 0 is where things get more complicated. 0 divided by 1/2, saying how many 1/2 are there in 0? There's none of them. That's simple. We have nothing, so there's clearly no 1/2 in them. But the other way now, 3/5 divided by 0 is asking how many zeros are there in 3/5? How many nothings are there in something? And that is a question for the philosophy department. How can you find a nothing in something? In math, we say that this is undefined. Anytime you see divided by 0, unless it's 0 divided by 0, which is its own little beast. But if you see a number that is a non-zero number being divided by 0, it's undefined. We just say we don't have a way of doing that. It's just undefined. So you can always write undefined. DNE is fine too. That stands for does not exist. You will sometimes see these horrible fractions. I just want to remind you that this bar, every bar in a fraction means divide. So you can just rewrite this as 3/5 divided by 2/7. It's the same problem. We just wrote it in a horrible way, but we know how to solve it. And then the last thing to remember is that PEMDAS still is going to apply when we're solving these kind of problems. And the fraction bar makes a group. So this 3/5 doesn't have parentheses, but you can imagine invisible parentheses, or you can remember that this is GEMDAS and it's a group. You have to resolve this first before you can do the rest of this problem. So we have to do 3 plus 5 before we can keep going with our problem that we're doing. Okay?